Hi everyone. So this is the third video that deals with multiplying and dividing rational expressions, and these problems are a little bit more advanced. Okay, and you'll see why. Again, definitely they are not monomials. They are all polynomials, and sometimes you'll have to, if you look here, this polynomial is in standard form. That's in standard form. That's in standard form. This one is not. So in some of these problems, you're going to have to put the polynomials in standard form first before you try to do anything. Okay? So I guess that's one more wrinkle in simplifying or multiplying and dividing rational expressions. So again, we're going to start with the same thing, right? The steps, which were, of course, keep, change, flip if it's a division, right? 2, factor completely, and then 3. And what we're going to do is make sure when we factor completely, we're going to say also put everything in standard form. Okay, make sure everything is in standard form. Okay, also we'll add that part, and then of course I'll cross cancel and then multiply across. Okay, everything else is the same. So we just added. Make sure everything is in standard form when you're doing the factoring. So let's go to our problem here. Got lots of space on this one, which is excellent. First one. And these also have a leading coefficient in them, right? As you can see. So 6y squared. So again, we know that that first one has to have maybe a 6y and a y. Or it could be like a 3y and a 2y, correct? So, I mean, it could be a combination of these. But I'm going to say, let's say, is that going to work? 6 and 12. So 3 and 2. I'll kind of play around with this. So if we wanted to use, again, borrow and payback, right? To do this, borrow and payback, maybe we'll just go through borrow and payback. So it's y squared plus 13y plus 36. And now if we factor that, that's going to be y plus, is it 6? 6 is 36, right? So it's going to be, let me see. So I could do 12, well, 6 and 6, right? Or I could do, that's 3 and 2, 3 and 2. I can do 9 and 4. Yeah, that's going to work, right? So 9 and 4. Okay? And then we borrow the 6's. So 6y plus 9, and then 6y plus 4. We factor each one. So 3, and then 2y plus 3, and then this one's going to be 2 times 3y plus 2, and then pay back one of the 6's. So, yep, we are right. Okay, so it's not going to be 6y and y, so it's going to be 2y plus 3 times 3y plus 2. Okay, and those are going to be their factors. So as you can see, sometimes the factoring is a little bit more involved, right? And if you FOIL this, you'll see that it does come out to that. 6y, and then 4y, 9, and 13, and 6, yes. And now here on the bottom one, I'm going to first put this as negative 5y plus 20, and then I'm going to factor it. I'm going to factor out a negative 5, leaving me with y minus 4. Okay? And then we're going to do our keep, change, flip. So we're going to flip this now, which means that now the denominator goes on top. So this is now going to be in the numerator. So I'm going to factor that right on the spot. Y, excuse me, minus 4 and y plus 2. That. And then now this is in the bottom. So that's going to be, and that's a perfect square. So it's 2y plus 3, 2y minus 3. Okay, there we go. Okay, and all our factoring is done. So our keep, change, flip was done, our factoring was done, standard form was done. Now we can cross cancel. So 2y plus 3 with a 2y plus 3 here. a y minus 4 with a y minus 4 here, and I think that's all we have. So our final simplified form is 3y plus 2 times y plus 2 all over negative 5 times 2y minus 3. Okay, type that in and go from there. So 3y plus 2 and y plus 2 all over negative 5 times 2y minus 3. Okay, and hopefully that's correct. That is correct. Okay, any questions? Okay. All right, let's go to this one now. It says the following equation is true for all real values of n for which the expression on the left is defined. What is a? So now we have to solve for a here, correct? And that's pretty, I mean, there's a, we could definitely solve for this. So how are we going to solve? We have to isolate it, right? So how are we going to isolate this a? Well, definitely we're going to have to put everything else on the other side, right? Besides a. So what we can do is we can basically flip this whole thing, or we don't have to flip the whole thing. We just multiply this denominator to 1. So it's going to be like this, right? It's going to be this is equal to the bottom. So we multiply both sides of the denominator, or if you want to, we can think about it as cross multiplying like this, right? So we're going to have basically n squared plus 24n plus 144, this thing times n squared plus 2n minus 3 is equal to a times n squared plus 11n minus 12, like that. And then, of course, divide both sides by n squared plus 11 minus 12, right? So we're going to divide by n squared plus 11n minus 12. And that's going to cancel out. So a is going to be equal to this thing. But we have to simplify it, right? So let's simplify it. Perfect square trinomial, right? So this one's going to be n plus 12 quantity squared times. This is pretty easy too. It's going to be n plus 3 times n minus 1 all over. And this is also pretty easy too. That's going to be n plus 12, n minus 1. Okay, and let's cancel. All right, n plus 12, we'll get rid of one of them. N minus 1, n minus 1, correct? And this is going to equal a, right? So what do we have left? We have n plus 12 times n plus 3 is equal to a. I believe that is it. So let's type it in. N plus 12 times n plus 3. Okay. All right. Chugging right along. And let's do one more. Okay. Here we have multiply the following and simplify the result. No problem. It's already a multiplication. So let's do it. Again, we're going to take out all of the GCFs first, right? Remember? So let's do it. We're going to have z. We can take out one z. That's going to leave us with z plus 9y squared. Okay? All over 5z times. Now let's factor this. This looks like a perfect square trinomial. Okay, how? Because you're going to have z's and you're going to have y's. Z's and y's. Okay? It's plus, but it's minus in the middle, so they both have to be negative. And it looks like it's going to be 9 and 2, no, 6 and 3, right? So 6 and 3. Okay, all divided by, and this looks like the difference of two squares. So that's going to be z plus 3y and z minus 3y. Okay? Again, don't be afraid because you now have two variables here. Just treat it like you would without the y's and just throw them in at the end if it makes you a little bit more comfortable. Okay? Let me see here. So we factor out a z here. That's correct. So z, yep, that is correct. Z plus 9y squared. Huh. I wonder if that's a misprint right there. No, it's probably not. Okay, so let's do our little canceling here. We got a couple of z minus 3's here. We got a couple of z's like that. And I think that's all she wrote. Okay, so this over that. So let's put our final answer in. We have z plus, where's my parentheses? Z plus 9y squared times z minus 6y all over 5 times z plus 3y. I think we got everything right. Z plus 9y squared times z minus 6y over 5 times z plus 3y. And that is correct. Okay, guys? All right, take care.